Good evening, dear participants. I welcome you all today for the last session of our IIT JAM mini preparatory workshop. Today we have as our resource person Dr. Dipak Jadhav sir, who is an associate professor at Srimati CHM College, Ulhasnagar. Over to you, sir.
Yes, thank you, madam. Good evening, all of you. Let me share my screen. Am I audible to all of you?
Yes, sir.
My, yeah, is my screen visible?
Yes, sir.
Okay, so last time we have recalled some results on infinite series. Let us have a quick glance. Necessary criteria for the convergence of infinite series, telescoping series, geometric series, and we have geometric series test for geometric series. And we know about divergence of harmonic series. And for series of the type alternating series, we have Leibniz test. Then for series of non-negative terms, we have comparison test, limit form of comparison test, ratio test, root test, Cauchy condensation test. Apart from this, we also have P series test, which says summation 1 upon n raised to P is convergent if P is greater than 1. And then we have little bit of knowledge about power series expansion or Taylor series expansion for a given function at a given point. And we know about radius of convergence of a given power series and interval of convergence for a given power series. So with this in mind, we will try discussing the problems of infinite series. So here is the first problem. Yeah, is it visible to all of you? Yeah. The sum of the series minus 1 raised to n upon n square plus n minus 2 is. All of you think on this. Okay, so let's see. Here, what is an? We can compare it with summation minus 1 raised to n, where n runs from 2 to infinity. Let us compare the series with this. We have an is equal to 1 upon n square plus n minus 2. So denominator, you have some quadratic expression in the variable n. So is it possible to factorize that quadratic expression? And if yes, then what are the two?
Yes,
Yeah.
sir. Yes.
What are the two factors?
N plus 2 multiplied by n minus 1.
Yeah, n minus 1 into n plus. Very good. So the thing is it possible to write it as in this form 1 upon n minus 1 minus 1 upon n plus 2? Such a thing I hope you have already observed. It is called as partial fraction. So is it possible to write? So let us simplify on the right hand side. Let us see what is the sum. Be equal to n plus 2 minus n plus 1 upon n minus 1 into n plus 2. So n get cancelled. You have 3 upon these two brackets. So this fraction, so there is some extra factor 3 is coming in the numerator. So how will you adjust that? We will adjust it here. We will divide by 3. Is it okay? So when you divide by 3 throughout, you will have cancel and you have the required expression 1 upon n minus 1 into n plus. Okay, this process of partial fraction. All of you see this. Okay, so then I want summation n from 2 to infinity minus 1 raised to n times n. So that is summation n from 2 to infinity minus 1 raised to n times this partial fraction. Because an we have split up with the help of partial fraction into fraction of two fractions. It is 1 by 3 times 1 upon n minus 1 minus 1 upon n plus 2. So this will be equal to 1 upon 3 is outside. Summation n from 2 to infinity minus 1 raised to n upon n minus 1 minus 1 raised to n upon n plus 2. ठीक है. Now the question is it possible to split this summation sign over these two fractions? I mean, is this term will be equal to this? What do you feel? Which result we are using of infinite series?
Yes, sir.
Yeah. So I hope all of you must have guessed the result. Algebra of
Convergent
convergent.
series.
Yeah. And why we know that the series is convergent? Because the question itself says we want to find the sum. That means series converges. And also you can check
By
series actually
yes,
converges.
sir.
Yeah.
By Leibniz test.
Yeah, by Leibniz test, or maybe you can use comparison and P series test. You can conclude series converges absolutely. In fact, so every absolutely convergent series is convergent, so this converges. Okay. But what happens if I write something like this then? Let us bring the sum from n from 1 to infinity. So how will it change? I want to write this sum from 1 to infinity. So what should I write here? What power of minus 1 and what should be in the denominator?
N plus 1.
Yeah, power of minus 1 is n plus 1. And what about the denominator? When n is 2, denominator is 2 minus 1, that is 1. So it is n. Yeah, is that okay?
Yes, sir.
And here also we'll write n from 4 to infinity, because when n is 2, denominator is 4. So n2 minus 1 raised to n. Doesn't matter. Okay. Did you follow this? We have changed some running indices, values of running indices. Here it was previously n runs from 2 to infinity, and then we have changed it to n from 1 to infinity with observation. Here also sum was running from 2 to infinity. So first term starts at 2 plus 2, that is 4. So we have started sum from n equal to 4 to infinity minus 1 raised to n. Okay. Once you have done something like this, then you have to recall power series expression for 1 upon 1 minus x. Anybody remembers? And that will be this 1 plus x square plus x squared. This is valid not for all x, but only for those x whose absolute value is less than 1. And then if I replace x by minus x, I may get something like this. 1 minus x plus x square minus x cube plus alternate plus minus. So radius of convergence is 1, but interval of convergence is slightly bigger than open interval minus 1 comma 1. It is minus 1. It is minus 1 less than equal to x less than equal to, sorry, strictly less than 1. Yeah. So you can replace x by minus 1 in this. So if you replace x by minus 1 in this expression, what you're going to get? Or how will you generate this kind of series? By using this power series. Yeah. I hope the first expression is okay for all of you. This highlighted yellow. Is this fine for all of you?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Yeah. So this is a kind of power series. It's not difficult to observe the equality of these two. But the further results in power series says within the interval of convergence, you can differentiate your series as many times as you want. Within the interval of convergence, you can integrate your series as many times as you want. So if I integrating term by term, we get, so integral on the left hand side minus x dx, and the integral on the right hand side 1 plus x plus x square and so on dx. So when I say integrating term by term, integral of infinite sum, we already know that integral of finite sum is finite sum of integrals. That's algebra of integration. But what happens if you have infinite sum? So in case of power series, you can integrate infinite sum term by term. So the result says this integration is 1 dx plus integral of x dx plus integral of x square dx and so on. So if you apply this, then you'll get on the left log of 1 minus x divided by coefficient of x, and on the integral on the right hand side is x plus x square by 2 plus x cube by 3 plus x raised to 4 by 4 and so on. And this is valid for minus 1 less than equal to x equal less than 1. Okay. So when I plug in the value of x equal to minus 1, what I'm going to get? Log of 1 minus minus plus 1 upon minus 1 is equal to minus 1 plus 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5 and so on. Transfer this minus sign on that side. You'll have log 2 is equal to 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus and so on. Is it okay? This. So you should not forget this series. We already noted that summation 1 by n, that is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, is a harmonic series. Harmonic series, and it is divergent. We already know. Is it okay? So this expression and this expression, there is only a slight change. Alternate signs are plus minus. So this falls under the category of alternating series. Alternating, and by Leibniz test, it converges. It converges. converges. ठीक है. So Leibniz test only guarantee about convergence of this alternating series, but Leibniz test doesn't tell you about where does this series converges. So this tool from higher mathematics, that is of power series, we have used that tool from higher mathematics and we concluded that this series converges to log. Is it okay? Now let's come back to our main question. We want this sum, summation n from 1 to infinity. So this is exactly equal to this 1 minus half plus 1 by 3 if you observe. Okay? Let me write this again. So what was that? 1 upon 3 summation 1 to infinity minus 1 raised to n plus 1 by n minus summation 4 to infinity minus 1 raised to n on n. So this first sum, so if you expand this 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. So this first sum converges to log 2. What about the second sum? Where does it converges? So if you expand this, sum starts from 4. So 1 by 4 minus 1 by 5 plus 1 by 6 minus 1 by 7 plus and so on. So this starts from 1 by 4 here. This part. Is it okay? This circled part. Highlight it by green. What you're going to get? The second part will be equal to first part is log 2 and the second part is to transfer this green part on the left and transfer log 2 on the right. We'll have 1 minus half plus 1 by 3 minus log 2.
5 by 6 minus
okay?
log 2.
Yeah, very good. Log 2, 5 by 6 minus log 2. When you open the bracket, you'll get 2 by 3 times log 2 minus 5. Yeah. So which option? Option D. Is it okay?
Sir, it's 5 by 18.
Yeah, 5 by
C part.
5 by 18.
5 by 18.
Yes, sir.
Okay, so you make the correction. Option C. Is it okay for all of you? Move on to another question.
Yes, sir.
Yes, sir.
Is it visible? There is something an and bn is given, and there are 4 options. An converges, bn diverges, summation an diverges, summation bn converges. Both series will converge or both series will diverge. Think on this. Try applying some test you already know. Okay, so let us look at summation A. Summation 1 by 3n plus 2 into 3n plus 4. So here an is, let us open the brackets. 9n square plus 18n plus 8. Is it okay?
Yes, sir.
What is the relationship between this and 9 by n square? 1 by 9 by n square. 1 by 9n square.
Less or equal to.
Yeah. How will you say that? How will you justify?
Because 3n square plus 18n plus 8 is greater than 3n square. So after
Yeah.
taking reciprocal,
Very good. But the simple logic is, if we decrease the denominator, then value of fraction increases. Is that okay? The denominator initially was 9n square plus 18n plus 8. We have just thrown away these two positive things, 18n plus 8. So I have decreased the denominator. So when you decrease the denominator, value increases. Okay. And if we increase the denominator, you'll have exactly reverse process. Then value increases. Sorry, decreases. Is it okay? Will you keep this in mind? Yeah.
Yes, sir.
Yeah. So you don't have to worry about what I'm doing, whether it is correct. Simple. If you decrease the denominator, value increases. If you increase the denominator, value decreases. Okay. And then it's easy. Summation 1 by 9 n square is nothing but 1 by 9 summation 1 by n square. It's convergent. Why? E-series tests. So by comparison test, what I can say?
And
Summation
converges.
here converges. So we got first series convergent. So this option is wrong and this option is wrong. Either you'll have from A or D. Let's focus on second. What is Bn? Bn is n cube plus cos of 3 raised to n upon 3 raised to n plus n cube. Okay. So how will you deal with this? There are so many tests. Comparison test, P-series test, ratio test, root test. So which test is applicable at which point of time? There is no definite formula or definite pattern so that you can guess whether this test is applicable, this test is applicable. No. By practicing more and more problems, you will have intuition that this is applicable or this is not applicable, and so. So here, choose Cn as n cube upon 3 raised to n. Compute. Limit n tends to infinity. Bn upon Cn. All of you do this. So Bn is n cube plus cos 3 raised to n upon 3 raised to n plus n cube into 1 upon Cn. So that is 3 raised to n upon n cube. So what are you going to get? Limit n tends to infinity. 1 plus cos of 3 raised to n upon n cube, and here you'll have 1 plus n cube upon 3 raised to n. Is it okay? We divided this term by this, and this term by this. Yeah. We have written something like this. What will be the limit of the numerator? Where does cos 3 raised to n upon n cube goes as n tends to infinity?
0.
Yeah, this is less than equal to 1 upon n cube. Whatever may be the angle, doesn't matter. Cos of that angle is bounded by 1. And you have denominator n cube, which is going towards 0. So this term will also go towards 0. What about denominator? Where does this goes?
0.
0.
N, yeah, the same argument. Denominator is going towards 0 faster than, sorry, denominator is going towards infinity faster than numerator. You can try applying L'Hopital several times, you'll get 0. So answer to this limit is 1. Good. So what I have achieved from doing this? So this complicated expression, I tried simplifying a little bit. Okay. So I got something like this. Now what can I say about? So I can apply limit form of comparison test, and I can say both series will behave alike. What can be said about summation Cn, summation n upon 3 raised to n? So I need to check whether this is convergent or divergent. You can simply use the ratio test or root test. If I use the root test, what I'm going to get? Mod an raised to 1 by n. What that will be? N raised to 1 by n whole raised to 3 divided by 3. Where does it goes?
1 by 3.
By 3. Because we already noted this special kind of sequence n raised to 1 by n goes to 1 as n become large, large, and large. So by ratio test, this series converges. By ratio test, summation Cn converges. So by limit form of comparison test, summation Bn converges. So what is option then? Both are convergent series. Is it okay? Yeah.
Yes, sir.
Getting answer may be easy, but writing that answer may be difficult. So you should also learn how to write mathematics. Quickly, can you tell me this next question? Visible to all of you? Whenever you have some polynomial expressions like this, there's some polynomial in the numerator and some polynomial in the denominator. It's always better to use limit form of comparison test. So this series, summation n square plus n plus 1 on n into n plus 1, you will like to compare it with, choose the highest power of n from the numerator, that's n square. Choose the highest power of n from the denominator, that is n square. So this is the right highest power of n from numerator. This is highest power from denominator. And then you have to see this. This is equal to summation 1. or probably you can try applying the necessary criteria. What does it says? Where does an goes?
To 1.
Goes to 1, which is non-zero. So this diverges. Because we have already seen a result. It says that if your series is convergent, then nth term should go to 0. Now in the next series given S2, what is that? Summation n square plus 1 upon n square into n plus 1. Here if you observe an is n square plus 1 upon n square into n plus 1. Where does it go as n tends to infinity?
0.
0.
0. So necessary criteria fails. Converse of the necessary criteria is not true. So we cannot conclude by using necessary criteria. So we need to apply some other test. The same logic works. Compare it with the highest power from numerator, that is n square, and the highest power from denominator, that is n cube. So you'll have something summation 1 by n. So this is your an and this is your bn. Then compute limit n tends to infinity of an upon bn. That is equal to n square plus 1 upon n square into n plus 1 into n by 1. The limit is 1. It is strictly greater than 0. So my limit form of comparison test, I can conclude summation an
Divergent.
and summation bn behaves alike. But do I have any information about summation bn? Summation
Divergent.
bn, diverges. It's a harmonic series as being harmonic series. So summation an also diverges. So which option is correct then? S1
D.
diverges. So also both. Yes, very good. Okay, can we move on to next question? Okay, try this question, all of you. There's something, a sequence is given. An n plus 1 upon n for all n belongs to n. We wanted to know that summation minus 1 raised to n plus 1 an plus 1 by n factorial is equal to one of the four options. So that means the series is convergent. Series is convergent. So let's compute an plus 1 n plus 1 plus 1 by n plus 1. Then an plus 1 into 1 upon n factorial. So what are you going to get? 1 upon n factorial. That will be equal to n into 1 by n factorial plus 1 by n factorial plus 1 by n plus 1 into n factorial. Is that okay? Yeah. We are just doing simple algebra. So what I'm going to get? term is n get cancelled. 1 upon n minus 1 factorial. 1 upon n factorial plus 1 upon the last term is plus 1. So summation n runs from 1 to infinity. Minus 1 raised to n plus 1 an plus 1 by n factor. That will equal to let me write it first. Minus 1 raised to n plus 1 upon n minus 1 factorial plus minus 1 raised to n plus 1 upon n factorial plus minus 1 raised to n plus 1 upon plus 1 factorial. Now again, I'll argue that the series converges. So by algebra of convergent series, I can split the summation sign. So if I split the summation sign, it will be n from 1 to infinity minus 1 raised to n plus 1 upon n minus 1 factor. 1 to infinity plus 1 raised to n plus 1 upon n factor minus 1 raised to n. Summation 1 to infinity minus 1 raised to n upon n plus 1 factor. So we want to calculate its value. So there is some value to this series has. We wanted to find its value. This is also has some final answer. This also has final answer. So that we can add all these three and we'll have the final answer for the problem. So again, we have to take help of power series. So we know that e raised to x. What is the expansion of e raised to x? 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial, because factorial term comes in the expansion of e raised to x, exponential function. Now here you have alternating series. The terms are alternating. You observe there is a term at the numerator which is minus 1 raised to n. So if I expand this, first will be 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3. Is it okay? Be like this. Can you expand the second?
Yes, sir.
Yeah. Second expansion will be 1 upon 1 factorial minus 1 upon 2 factorial plus 1 upon 3 factorial minus 1 upon 4 factorial and so on. What about the third expansion?
Minus
1 upon
2
Minus
factorial.
1 by 2 factorial plus 1 by 3 factorial and so on.
minus or plus?
Plus.
Yeah, yes, good. There is something like alternating terms. So which value of x will give me this power series expansion for e raised to x is valid for all x in R. So in particular, it is valid for x equal to 1. So put x equal to 1 in this. What are you going to get? E raised to minus 1. 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial and so on. So here only you'll have your answer. You just have to adjust the terms. You'll get your answer. See what you're going to get your answer.
E raised to power minus 1.
Option A, B, C, D.
D.
D. So all of you please check. Answer is D. Just have to go on adding. That's it. You have to use this expansion and see what is the sum of first bracket, second bracket, and third bracket, and add. That will give you answer. Is it okay? Can we move on to next question? Check this out. Very good. Arpita, Tanya, very good. Find those values of alpha for which the given series is convergent. So it's given summation 1 to infinity 1 plus alpha by n whole raised to n square is convergent. That's given. Okay, so it's already given convergent. So we want to find the value of alpha for which is convergent. For all values of alpha, this may not be convergent. That means for some values of alpha, it may be convergent. For other values of alpha, so basically alpha belongs to real number. And we wanted to check for which values of alpha being a real number, the series converges. So let's apply. So here is an. An is 1 plus alpha by n whole raised to n. So whenever you have power n at the place of power, it is always tempting to use root test. It's always tempting to use root test. So let's apply root test. Yes. So in case of root test, we need to compute mod an raised to 1 by n. 1 plus alpha by n raised to n square whole raised to 1 by n. Simply 1 plus alpha by n whole raised to 1 power of n will get cancelled. And then we compute limit of that as n tends to infinity as per root test. 1 plus alpha by n whole raised to n. So how will you manipulate this term?
raised to power
So
alpha.
Algebra says it is less than 0. Let's see whether it is less than 0. Yeah. Somebody said how to manipulate this. You divide by alpha and multiply by alpha. And then what you will get? Limit of this e raised to alpha. So I hope we are aware of the result. 1 plus 1 by n raised to n is equal to e. Okay, good. So by ratio test, what are you going to have? Check.
The limit values will be less than 1.
Yeah. E raised to alpha is less than 1. Then summation an converges. Means take, how will I get the bound on alpha then? Take logarithm on both sides. So alpha times log e less than log 1. So when you're taking log on both sides, so you're using the property that log x is increasing function on its domain. What is the domain of log x? Open interval 0, infinity. So we are using that. So that implies alpha is less than 0 because log e is 1, log 1 is 0. Very good. So we got the condition for which values of alpha the series converges less than 0. Is it okay? Please observe it carefully. If you have any doubt, you can ask.
सर
Yes.
अगर अल्फा की वैल्यू लेट से हम कोई नंबर ले जैसे -1 हमने लिया
हाँ
तो वे सीरीज कन्वर्स कर जाएगी 1/e पे। ठीक है
How?
बट जो नेसेसरी कंडीशन है फिर उसका क्या जो सीरीज कन्वर्जेंस के लिए होती है कि अगर कोई सीरीज कन्वर्जेंट है तो लिमिट शुड बी इक्वल्स टू 0।
हाँ. Yes.
तो वो तो यहाँ पे सेटिस्फाई नहीं होगी।
What is the limit of an? What is an here? That means you're asking limit of this, no? Necessary condition says your series is converted, then an goes to 0.
यस सर।
Yeah. So what is the limit of an? Let me write here. Okay, let me- Limit of an 1 plus. Why do you feel it is not going towards 0? Suppose you put alpha is equal to -1.
-1
This
हाँ।
is, yeah. So you have limit n tends to infinity 1 minus 1 by n s to n square. Where does the limit of this goes? There is a n at the power and n at the base. So we will use, suppose the value is L. Okay. So we'll use the log on both sides and we'll try to simplify. So what are you going to get? Let me write here. Log L is equal to limit n tends to infinity n square into log of 1 minus 1 by n. Is it okay?
यस सर।
This goes to infinity. And what about this part? As n become large, large and large,
0।
this goes to 0. So it is something like infinity into 0. So either you convert 0 by 0 form or infinity by infinity form. So suppose you convert 0 by 0 form. So what are you going to get? Limit n tends to infinity log of 1 minus 1 by n upon 1 by n square. And this is 0 by 0 form. Let's apply L'Hopital. What are you going to get? 1 upon 1 minus n into 0 minus of minus 1 by n. That's the derivative of numerator. What the derivative of denominator? Minus 2 by
बाई
n.
n क्यूब।
Yeah, good. So let's see what power of n survives where. So if I simplify this will go to 0 anyway. Sorry, this will go to 1. Yeah, as n become large, large and large. What will happen to this?
Negative infinity.
Negative infinity. It's 1 by n square, and here we'll have 2 by n cube. So n cube by n square is like this. Yeah, minus.
सर हाँ माइनस भी आएगा।
That goes to minus. Yeah, it goes to negative infinity. Very good. But this is log L. When does, well, for what values of L, log L goes to minus infinity?
0.
0।
L approaching towards 0 from right hand. Yeah. But what is L? L is this limit, required limit. Yeah. Is it okay? Do you agree with that limit goes to 0?
यस सर यस सर। लास्ट में मैंने लॉग एल नहीं लिया इसके लिए वो माइनस इन्फिनिटी आ गया।
Okay, okay,
ओके।
fine, fine. No worries. So let's move on to, okay, this is, I think, very easy. You can just read and tell me the answer here itself. for a convergence of a series, summation a of real numbers, the condition limit n tends to infinity, a n equal to 0. And this condition, limit n tends to infinity, mod a n raised to 1 by n are both necessary, both sufficient. First is necessary, second is sufficient. What can you say about this condition? First condition, let us focus on first condition. What do we call this condition?
Necessary condition.
Necessary. Good. What about the second?
Sufficient.
Yes, sufficient. It's not necessary. There are some examples of series for which this limit may not be 0, but your series is still convergent. Okay. So this is just a sufficient condition. It's not necessary. This is the necessary and this is the sufficient. So correct answer is first is necessary and second is it okay for all of you?
Yes, sir.
Okay, good. Let's move on to the next question. Yeah. Is it visible? What can you say about this? Very quick. What do you mean by divergent?
Absolutely convergent.
Absolutely convergent. So some of you feels it is absolutely. What do you mean by absolutely convergent? You take the absolute values of the terms. That means it become 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial. We have already seen whenever you have factorial in the picture, you should not forget e raised to x. 1 plus x upon 1 factorial plus and so on. And this is valid for all x in R. There is no bound on x. This power series has radius of convergence equal to infinity. So this power series converges for every value of x in real numbers. So whatever x you plug in here, x can be 1 lakh or x can be 0, x can be anything. So if you substitute x is equal to 1 in this, what are you going to get? E raised to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus x. So this expression will be exactly equal to right hand side except the term 1 upon 1 factorial. So this is equal to e minus 1. Is it okay?
Yes, sir.
Yeah. So this series, if you take the absolute values, that gives me finite sum. So that means the series converges absolutely. So every absolutely convergent series is convergent. So this option is wrong. Conditionally, it's not conditionally convergent. I hope all of you know what do you mean by conditionally convergent. For an, if summation mod an diverges and summation an converges, then summation an converges conditionally. Is it okay? Yeah. If you are not still clear, spend some time on this. We move on to next. Here is the next question. I hope it is visible to all of you. Spend some time on this. It is summation n from 1 to infinity an. So what is an here? E raised to 4, e raised to minus. Right in the denominator, e raised to n. Where does this go as n tends to infinity? Numerator is also going towards infinity. Denominator is also going towards infinity, but you can observe denominator is exponential kind of thing. So denominator will go towards infinity faster than numerator. So quotient will go towards 0. If we apply the root test, mod an raised to 1 by n, what are you going to get? E raised to n square all raised to 1 by n. What that will be? N raised to 1 by n raised to 4 on e raised to n. Numerator is going towards 1. Denominator is going towards infinity. So it will go towards 0. So it is less than 1. Can I say like this? All of you agree with this?
Yes, sir.
Yes, sir.
Very good. So by ratio test, I can say the series converges. By ratio test, you can also observe it by this way. All of you pay attention. What is n? N raised to 4 upon e raised to n square. Is it okay? Yeah? Okay. Look at here. What is e raised to x? I have a nice power series expansion for e raised to x. What is that? 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on. And this is valid for all x in R. So can I have a power series expansion for e raised to n square? Yes. Put is equal to n square in this expansion. So what I'm going to get? Numerator n raised to 4. I'll just write few terms. 1 plus. What will be the next term? N square upon 1 factorial. The next term, n raised to 4 upon plus. The next term, n raised to 6 upon 3 factorial plus. Dot, dot, dot. Is it okay? Yeah? Did you follow this?
Yes, sir.
I have just substituted power series expansion for e raised to n square. Now I am keeping numerator as it is, but I am deleting all terms from the numerator except the one term n raised to 6 upon 3 factorial. What will be the relationship between this and this? Use the same logic. If you decrease the denominator, value increases, and if you increase the denominator, value decreases. So what are we doing here? Are we decreasing denominator or increasing? So I'm deleting these terms. I'm deleting this, and the rest of this. All these terms I'm deleting, and all of them are positive. So I have deleted positive terms. That means I have decreased the value of the denominator. So overall value will increase. All of you agree? Yeah.
Yes, sir.
Very good. So an will be less than equal to, let me simplify this, 6 into 1 upon where? Very simple. Yeah. And we know this converges as being P series. Obviously by P series test. So what I can say? By comparison test, summation an converges. All of you agree with this? Alternate answer?
Yes, sir.
Yes, sir.
Yes, very good. Let's move on to another. Visible? So an is sine n upon e raised to 2n. So absolute value of an less than or equal to 1 upon e raised to 2n. Can I say like this? And then again I can apply the power series expansion for e raised to x, and I'll have this equal to 1 plus 2n upon 1 factorial plus 4n square upon 2 factorial and so on. Again, I'm using the same trick. This will be less than or equal to 2 factorial upon 4n square. I'm deleting all terms except this term. And all terms are positive, so your value will increase. So let's convert this. So by comparison test, summation an converges absolutely. Yeah. Can you think on the same line for bn? Let me write this equal to n square sine n whole square upon e raised to n. The absolute value of this is an equal to n square upon e raised to n. So this will less than equal to what? Check what you will get. Yeah. Square upon 1 plus n upon 1 factorial plus square upon 2 factorial plus n cube upon 3 factorial plus n raised to 4 upon 4 factorial plus and so on. So I'll keep this term because that will guarantee the convergence. Yeah. Just 4 factorial upon n. So this converges. So by comparison test, summation bn also converges. All of you agree with this?
Yes,
So
sir.
both a and yeah, both a and both bn also. You have any doubt in this? Can we move on to next question? This question. Let's see this. Yeah. Let's see this. There is some function f bivariate f of m comma n. Find like this. If n is greater than n, 0. If n is less than m, then there is some expression like this. N is equal to m, you have something like this. So you want to find out this double sum. So let's consider this first. M from 1 to infinity, n from 1 to infinity, f of m comma n. So let me fix the value of m. M value of m here. Let me write the value of m here. Let me observe. See, outside sum is n. So let me take m is equal to 1. Okay. And then I just wanted to observe what is this inside sum will give me for m equal to 1. So summation n from 1 to infinity, f of m is 1. It is fixed. We are not changing that. N is varying. So that will be equal to f of 1 comma 1 plus f of 1 comma 2 plus f of 1 comma 3 and so on. So what are we going to get? What is f of 1 comma 1? Apply the definition and tell me.
1.
Very good. 1 plus rest of these are 0. If you apply the definition carefully, because whenever you have second index bigger than first index, functional value is 0. So here the second index 2 greater than first index, second index 3 greater than first index, and so on. So answer is 1 plus 0 plus 0. Very good. Let's see what happens if m is equal to 2. N from 1 to infinity, f of, now m is 2. So let me fix the value of m as 2, 2 comma n. Let me expand this sum. F of 2 comma 1, f of 2 comma 2, f of 2 comma 3. What is the first value?
1/2.
Minus 1 upon 2 raised to 2 minus 1. Minus, there's a minus sign. Good, you did it correctly. Plus, what is f of 2 comma 2? 1. And the rest of the things are 0. So what I'm going to get? 1 minus 1 upon 2. Is it okay? Yeah. So that's 1 by 2. Very good. Let's observe m equal to 3. What happens? F of 3 comma n. That is f of 3 comma 1 plus f of 3 comma 2 plus f of 3 comma 3 plus and so on. F of 3 comma 1.
Minus 1/2 square.
Yes, very good. Plus, and the next term?
Minus
Minus, minus 1 upon 2. And the next term? 1. And the rest of the term? 0. So what you'll have? 1 minus 1 by 2 minus 1 by square. Yeah. So this will be equal to what? 1 minus 1 by 2 minus 1 by 4. क्या मिलेगा ये? 1 minus 0.75, 1 by 4, 1 by 2 square. Yeah. All of you agree with this? Let's see what happens if m is equal to 4. So, n from 1 to infinity, f of 4 comma n. F of 4 comma 1 plus f of 4 comma 2 plus f of 4 comma 3 plus f of 4 comma 4 plus and so on. So this first term will be minus 1 upon 2 raised to 3. Now we already guessed the pattern. Minus 1 upon 2 raised to 2 minus 1 upon 2 raised to 1 plus 1 plus 0, 0, 0 and so on. So this will be 1 minus 1 upon 2. Let me write in reverse order. So we'll not go on, keep on adding. We'll use next of the sum. Looks like something geometric progression. So I'll use the result from geometric progression. So what I'm going to get? 1 minus 1 by 2 common. What left inside? 1 plus 1 by 2 plus 1 by 2 square. Do I know this finite sum? Use the geometric series formula. So this will be 1. What are you going to get? Minus 1 by 2 cube upon 1 minus 1 by 2. Yeah. This will be equal to 1 minus 1 by 2 into 1 minus 1 by 8 upon 1 minus 1 by 2 is 1 by 2. So this 1 by 2 get cancelled with this one. What you're left with? 1 minus 1 plus 1 by 8 is 1 by 2 cube. Okay, good. So for m is equal to 1, we have 1. M equal to 2, we have 1 by 2. M equal to 3, we have 1 by 2 square. m equal to 4, we have 1 by 2 cube, and so on. What are you going to get? Let me write summation m from 1 to infinity and 1 n from 1 to infinity. F of m comma n will be 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 raised to 4 and so on. So this is again a geometric progression. Where does it converges? 1 upon 1 minus half. That's 2. Do you agree with this? Yeah?
Yes, sir.
Yes. Okay, good. Similarly, with a similar fashion, we can figure out the second sum. Let me do it for summation n from 1 to infinity, summation m from 1 to infinity, f of m comma n. Let's fix the value of n is equal to 1. Let's see. M from 1 to infinity, f of, what do you feel? Will you be going to get the same answer or different answer? What is your intuition says? Very difficult to say anything about this. Let's expand. N is 1 fixed. So let me substitute n is equal to 1. So this is f of 1 comma 1 plus f of 2 comma 1 plus f of 3 comma 1 plus and so on. What is f of 1 1? That's 1. What is f of 2 comma 1? F of m comma n is defined like this. So I want f of 2 comma 1. So n, this index is less than first index. So this definition, minus 1 raised to 2 raised to 2 minus 1 is minus 1 upon 2. All of you agree? Term in our expansion is f of 3 comma 1. What will be that? Minus 1 upon 2 raised to 3 minus 1. That is minus 1 upon 2 square. Is it okay?
Yes, sir.
Yeah, I hope all of you are also working with me simultaneously. So this is minus 1 upon 2, minus 1 upon 2 square, minus 1 upon 2 cube, minus 1 upon 2 raised to 4 minus and so on. Okay, I'll pull out minus half outside. What left inside? 1 plus 1 by 2 plus 1 by 2 cube plus 1 by 2 raised to 4 and so on. That's again a geometric progression, but this time it's infinite. So 1 upon 1 minus half. So what are you going to get? 1 minus 1 upon 2 into 2. 1 minus 1, that's 0. Do you agree with this?
Yes.
Yes, sir.
Yes. Yeah. Similarly, check for n equal to 2. Summation m runs from 1 to infinity. F of m comma 2 will give you 0. And so on. So double sum will be
0.
0. Very good. So what is the final answer then? This is 0 and this is so strange. If you interchange, if you rearrange the terms of the series, you are getting two different sums. One is 0, another is 2. It's a double sum, not single sum. Spend some time on understanding this. Yeah. Can we move on to next?
Yes, sir.
This sum. All of you try this. Let's compute apply definition. We want to find where does this series converges. That means we want to find its sum. So there are only two ways we can find sum. Either by using definition, or possibly it is alternating kind of series, or possibly it is you can apply geometric series test. So let's apply the definition here. Let's compute Sn. K from 1 to n, 1 by ak square minus 1 by ak plus 1 square. Let me expand the term. 1 by a1 square minus 1 by a2 square plus k equal to 2 by 2 square minus 1 by a3 square. Do you see that some terms are getting cancelled in between? Yeah. What are all the terms? These all in between terms get cancelled. We are left with 1 by a1 square minus 1 by an plus 1 square. A1 is already given. That's 1. You can use that. 1 by an plus. Okay. So limit of Sn equal to 1 minus 1 by an plus 1 whole square. Where does it goes? 1 minus 1 upon an plus. Where does an goes? This is an goes to 2. So an square will go to 4. So this is 3 by. Yeah.
Yes, sir.
Yes, sir.
Very good. Let us have a similar kind of interesting question. Visible to all of you. Here it is n plus 1 upon n square plus 1 into n square plus 2n plus 2. Okay. We have already seen at the beginning of the lecture, if we have two brackets in the denominator, possibly we can apply partial fraction and we can answer the question. So try applying partial fraction. Is it equal to 1 upon n square plus 1 minus 1 upon square plus 2n plus 2? Is it equal to that? Check, all of you.
Yes, sir.
Yeah, it is exactly. Okay, good. So when I try computing Sn, summation k from 1 to n, ak, that's nothing but a1 plus a2 plus a3. Is a1 1 by 1 square plus 1 minus 1 by 1 square plus 2 into 1 plus 2 plus a2 1 upon 2 square plus 1 minus 1 upon 2 square plus 2 into 2 plus 2 plus a3 3 square plus 1 minus 1 upon 3 square plus 2 into 3 plus 1 plus and so on. The last term will have 1 upon n square plus 1 minus 1 upon n square plus 2n plus 2. Okay, so you need to simplify all the terms and see whether these are getting cancelled and so on. It's not immediate that, yes, the terms are getting cancelled. You need to simplify further. Can we do something with the original expression itself? First fraction is 1 upon n square plus 1. The second fraction, you have 1 upon n square plus 2n plus 2. So this tempting me to write like this: n plus 1 whole square plus 1. Do you believe that n square plus 2n plus 2 will be equal to this?
Yes.
Yes, sir.
Yeah. Okay. Plus. What happens when we write something like this? If I write Sn, a1 plus a2 plus n square. So a1 will be 1 upon 1 square plus 1 minus 1 upon 2 square plus 1. a2 will be 1 upon 2 square plus 1 minus 1 upon 3 square plus 1 plus and so on 1 upon n square plus 1 upon minus n plus 1 whole square plus 1. So you can see the terms are getting cancelled easily. What you are left with 1 upon 2 minus 1 upon n plus 1 whole square plus 1. It's easy to compute the limit. It will go to 5. Is it okay?
Yes,
Because
sir.
sometimes you may need to simplify a bit further and so. Okay. I'll give some. Try them. The sum you can try. I hope the sums are visible to all of you. Yeah. You can try all the sums. Apart from this, you all have questions, question bank. All past year questions, you can try solving the sums. Is it okay? So questions. See, based on power series, the question visible. Let an be a sequence of real numbers such that summation an x minus 2 raised to n converges at x equal to minus 5. So first of all, this is a power series expansion, power series expression. What is the center of this power series? 2. So here it's a center of this power series 2. And where does minus 5 lies? Here we'll have 1, 0, minus 1, minus 2, minus 3, minus 4, and here somewhere we'll have minus 5. It is given that this converges at here. So we have seen a result which says that if a power series at x is equal to x naught, then it also converges a minus x naught, absolute value of x naught, to a plus absolute value of x naught. Where what is this? A is center of that power series. Center of that power. So this is the center of the power series. And it converges at minus 5. How much far this minus 5 from? 1, 2, 3, 4, 5, 6, 7. So it converges from here. You have to add 7 on this side. What you will get? 9. So within this interval it converges. Yeah. So which option is correct then? series converges at 12. Is it correct? No, because 12 is outside. X equal to 5 is lies inside somewhere here. 2, 3. It converges at x equal to. Okay. So one should be aware of all the results, everything when you go for competitive exams like IIT JAM. Okay. What about this quick question? Visible? Summation Bn, is it convergent? Summation Bn. Summation sin 1 by n. This is a option B. Satyaprata said option B. So this is divergent. Divergent. Very good. And the second one is convergent. What we need to use is limit form of comparison test carefully. That will give you the result whether the series convergent or divergent. Is it okay? And the option B is true. Very good. Let us have this. I don't know. How much time do I have? Yeah, is it visible? This is, there are two functions f and f inverse are given in terms of power series. F of x is equal to n from 1 to infinity, an x raised to n, and f inverse of x is summation 1 to infinity en x raised to n. It's given that f inverse is an inverse function of f. So what do we know about that then? F compose f inverse is identity, and that is equal to f inverse compose f. Yeah. Okay. Okay. So how will you compute f compose f inverse or whatever f inverse compose f of x? How it is different? F of f inverse of x. Yeah. That will be equal to f of f inverse of x is this summation n from 1 to infinity bn x raised to n. So that is equal to, let me expand, b1x plus b2x square b3x cube and so on. You apply f on this. What are you going to get? Tell me. F of x is this. A1 times this bracket. All of you agree with this? b1x plus b2x square plus a2 times this bracket square. b1x plus b2x square plus a3 times this bracket square and so on. This is what you're going to get. Yeah. Is it okay?
Yes,
Now
sir.
there is some information is given. A1 is 2, A2 is 4. Then we want B1. A1 is 2, 2 is 4. We want B1. A1 is 2, A2 is 4, and then we want B1. Okay, let's see. But what do we know about this? F compose F inverse of X is X. It's identity function. Let's compare the coefficient of X on both sides. On right. On the right is 1. What is on the left? What is the coefficient of X in this expansion?
A1 into B1.
Yeah, very good. See, this bracket has a square. So when you expand this bracket, you will never have term containing x. When you expand this square, you will never have term containing x. Do you agree with this? Yeah?
Yes, sir.
Yeah, very good. So where will have term containing x? Here itself, here only. And what is that? That's nothing but a1. Have a1, b1 is equal to 1. A1 value is known to us, 2 times b1 is equal to 1. So b1 is 1. Very easy. Is this okay?
Yes, sir.
Yeah. So with this, I wind up my session. I give you all the best for your exam that you are going to face on 2nd February, IIT JAM exam. Yeah.
Thank you
Yes,
so much,
Madam.
sir.
Yeah, it is over
Yes,
to you.
sir. Yeah. Thank you so much, sir. So, dear students, here we come to an end to our IIT JAM mini preparatory workshop. I take this opportunity to thank our resource person, Dr. Dipak sir, for his valuable time and for sharing his expertise with us. I thank all my department members whose diligent hard work has made this possible. And I would also like to thank the dear participants who have joined us after their regular college hours and made this workshop a huge success. Now, a few points to note for dear participants. We have uploaded all the lecture videos till day 8 on our Wilson College YouTube channel. The remaining videos will be uploaded soon. We will be scheduling a 50 marks online mock test on 25th January, that is next Saturday, from 6 to 7:30 p.m. The link for the same with relevant instructions will be shared via email. We will be soon giving you the certificate of participation based on your percentage of attendance and attendance of mock test. It is mandatory to attempt mock test for certificates. Once again, I thank you very much and all the very best to all your future endeavors. One more thing, the link for today's resource person's feedback is shared in the chat box. Please give your valuable feedback. Now, a quick request to just open your camera so that we can have a small group photo. Date for mock test is 25th January. 25th January, 6 to 7:30. We'll be sharing the details via email soon. So, Tina ma'am, is the screenshot done?
I'm taking it. Just 1 minute.
Okay, okay. Please switch on the cameras. It's a group photo.
One more.
Done?
Yes, it's done. Thank you.
Okay, thank you. Thank you so much, Deepak sir. Thank you, students.
Thank you.